Stanley Meyer's Voltrolysis Process Overview. Stanley Meyer's Voltrolysis process utilizes high-frequency voltage pulses to split water molecules into hydrogen and oxygen without traditional electrolysis or electrolytes. Materials and equipment needed. Water fuel cell, WFC. Cylindrical or tubular electrodes, typically stainless steel. Non-conductive container, glass or plastic. High-frequency voltage generator. Pulse width modulation, PWM, power supply. Variable voltage and frequency control. Circuit components, diodes, inductors, capacitors, transformers. Distilled water, to ensure purity and avoid impurities that could interfere with the process. Construction of the water fuel cell. Electrodes. Use stainless steel tubes. Ensure they are clean and free from contaminants. Cell assembly. Arrange the electrodes in a non-conductive container so they do not touch each other. Connect the electrodes to the high-frequency voltage generator, ensuring proper insulation to prevent short circuits. Setting up the circuit. Voltage generator connection. Connect the PWM power supply to the electrodes. Ensure the power supply can vary both voltage and frequency. Circuit design. Incorporate diodes to rectify the current, ensuring unidirectional flow. Use inductors and capacitors to create a resonant circuit. This helps in generating high-frequency pulses, which are crucial for the Voltrolysis process. Process steps. Fill the cell. Pour distilled water into the water fuel cell until the electrodes are submerged. Initial power settings. Start with a low voltage and frequency on the power supply. Gradually increase the voltage while monitoring the system. Pulse modulation. Adjust the PWM settings to create high-frequency pulses. The goal is to find a resonant frequency where water molecules are efficiently split into hydrogen and oxygen. Observation and adjustment. Look for the production of gas bubbles on the electrodes. Fine-tune the voltage, frequency, and pulse width for optimal gas production. Gas collection. Use a gas collection setup to capture the hydrogen and oxygen gases produced. Ensure proper safety measures are in place as hydrogen is highly flammable. Safety precautions. Electrical safety. Ensure all electrical connections are secure and insulated. Avoid direct contact with the power supply when it is on. Hydrogen handling. Collect hydrogen in a well-ventilated area. Avoid any open flames or sparks near the gas collection area. Protective gear. Wear safety goggles and gloves while handling the water fuel cell and related components. Troubleshooting. No gas production. Check all electrical connections. Ensure proper contact between electrodes and power supply. Adjust the frequency and voltage settings. Low efficiency. Fine-tune the frequency and voltage settings. Ensure electrodes are clean and free from contaminants. Overheating. Reduce the voltage and frequency. Ensure the cell has adequate ventilation but is sealed cap. Conclusion. Stanley Meyer's Voltrolysis process uses high-frequency voltage pulses to split water molecules into hydrogen and oxygen efficiently and makes nanobubble water fuel, which is not grounded to earth or air or engine block. By carefully constructing the water fuel cell and tuning the power supply, it is possible to replicate Meyer's claims of enhanced hydrogen production. Always prioritize safety and conduct thorough research before attempting to replicate this process. Hydrogen hot rodding is real and spreading.